Now suppose the cylinder, this is the cylinder, and it is getting separated like this due to the pressure acting like this. Pressure is acting like this, and due to that the cylinder is getting separated. Okay, pressure is acting like this and the cylinder is getting separated to two parts. So consider this portion, pressure is acting like this. So the stress to resist that is acting throughout the thickness. Like when it gets separated like this, when we look from here, it will be like a circle. So throughout the thickness of that circle, inside it will be hollow. So throughout the thickness of the circle, stress will be acting in opposite direction to that pressure. Okay, in this, the pressure is acting like this. That's why it is going this way. So here when we are looking, it is a circle, and throughout the thickness of the circle, inside it is hollow. So throughout the thickness of the circle, to resist this pressure, the stress is acting like this throughout the circle, thickness of the circle. So when you are looking from here, I told it's like a circle of thickness T, and diameter, internal diameter is D. Okay, this is the portion which I have shown like this. The pressure acting inward throughout this circle area. Okay, when we look from here, it will be a circle which thickness T, and inside it will be hollow, but we are looking from here, this solid portion we can see. So it will be like a circular area. So this pressure is acting in this circular area actually. Circular area. Here the pressure was acting. The top will looking, this thickness T will be there, inside is hollow, but bottom like this solid portion is there. So we are getting a rectangle. So that pressure is acting on that bottom portion, rectangular area we are seeing. So that pressure is acting in a rectangular area. Here the pressure is acting in a circular area. There the stress is only acting along through this thickness. Okay, circumference, thickness. This is pressure is acting in an area. This is along the circular length. The stress is acting. So this is the main concept. Now we'll see the two case equations. Okay. So now let's see the two cases. Okay, so stress due to fluid pressure P. There are two types, that is circumferential stress or hoop stress and longitudinal stress. This is the case of circumferential stress, that is the stress which is acting along the circumference. Okay, I told the P is acting along the circumference in this case. Okay, and longitudinal stress means the stress which is acting longitudinally, that is this one. Okay, this stress is acting longitudinally along the lengthwise direction of the cylinder. This stress is acting along the circumferential direction of the cylinder. Okay, that is why it is known as circumferential stress, and as it is along length, it is longitudinal stress. Sigma 2 and sigma 1 is the hoop stress or circumferential stress. So first case we will see, that is circumferential stress or hoop stress. Okay, now we'll see the force due to this fluid pressure. Due to fluid pressure there is a force, and when that exceeds the resistance force due to this sigma, that is hoop stress or circumferential stress. When the force due to P exceeds the resistance force generated in the material due to this circumferential stress, what happens? The cylinder will burst like this. Okay, so for limiting case we will take equal to the force due to P equal to resistance force due to sigma. Sorry, we'll write sigma 1. Okay, now we'll find the force due to pressure. So I told the P is acting on the rectangular area like this. This rectangular area P is acting when we are looking from top. Okay, the solid thickness and the bottom solid portion we'll see like a rectangle, and on this the P is acting. Okay, so P into force is P into internal D into length L, that is P into D into L. Now resistance force due to sigma 1. Okay, so what is that? The stress is acting along this thickness. When we take this portion, the sigma is acting upward along the length. Sigma is acting upward. because it is getting separated like this. With this portion it is getting detached. Okay, and this portion we will see in the longitudinal case. So now we are seeing this. So along this length sigma is acting upward. So sigma into, this is L into T. The two portions are there. So 2 into L into thickness. Sigma 1 into 2 into L into thickness. Okay. Then L cancels. So sigma 1 becomes equal to PD by 2T. Okay. Sigma 1 equal to PD by 2T is the expression for circumferential stress or hoop stress. So in the next video we will see the expression for longitudinal stress sigma 2. Thank you.